Okay, to continue where we left, we wanted to have the complete overview about how this architecture is. So, deep diving into it, first and foremost, the user. So, the user, let me zoom in a bit and make this, yeah, this looks good. So, first and foremost, the user, when the user, let's say it's me, when I'm trying to log in into the tsabunka.com/admin, we are trying to do the face recognition. We will have the facial recognition part as well, seen later. So there is a face recognition where we recognize whether it is stages or not. If it is stages, then we are in. If it is not, if let's say Shah Rukh Khan is trying to log in, he is not Tejas because his face doesn't identify as Tejas. So not Tejas, he will not be able to log in. And this architecture remains the same, Route 53 DNS, CDN, followed by the S3. Now in S3, we are being very specific. We are trying to go inside the tsavunka.com/admin for that specific dist folder, to load that specific website or the admin page. It goes to the API gateway. We are trying to verify that. From the API gateway, we are trying to use this Express API. What is this Express API? We will have a look. And then we are trying to do the login. In the login, we are trying to see with the username, password, as well as the user, who has been authenticated. So the user who is trying to get authenticated, if its token, the the two-factor token, whether it matches. If it matches, then we will have the token and the bearer token value fetch from the SSM. Once we get that value, there is an admin authorizer which extracts the token, verifies if this token is available in the JWT token, and then we are logged in. Then we are logged in into the admin under admin/dashboard, where we can see all the functionalities. One of the functionality was to see the YouTube, from the YouTube, how many viewers I have, how many videos I have uploaded, so on and so forth. That functionality is done by this specific Lambda, admin YouTube metrics. Similarly, the functionality of GitHub contribution, the code contribution is handled by this admin GitHub contribution Lambda. Then we have Cost Explorer for the AWS part, where we are trying to fetch how much of cost usage we are trying to see based on the services, based on the everyday or yearly usage. For that, we have this admin Cost Explorer Lambda. And then if you want to set up the TOTP, which is time based one time password, in order to set up that, or you want to get that status, or you want to generate a new secret, we have this admin setup TOTP Lambda, right? So this admin dashboard, we have this many lambdas which does the dedicated functionalities, either fetching the YouTube data, fetching the GitHub contribution, or directly speaking with AWS to fetch the Cost Explorer. As well, we have the setup TOTP Lambda to set up the token, the time-based one-time password token, or to fetch that token as well. We have this specific functionality. All this been authenticated or authorized by admin authorizer, which is which lets every request to be validated whether in the authorizer Lambda, whether this bearer token is present or not. Only then you're trying to go inside the admin's dashboard. Majorly, these are the backend lambdas or backend services. Similarly, for the Express API, I said I'll come back because this is a project which is already developed previously. We will have a look in a minute. Um, as well, we have the complete previous setup of the version one, the front end app with the DNS, CDN, as well as the T Sabunkar. This remains the same. To explain a bit about the Express API, you remember I said I'll come back on the Express API. Previously, I'll put a link in this YouTube video in the description about how the face verification was happening. It is quite simple, huh? This has been already been showcased previously as well, how this was developed, how it works. From the image recognition project, we have seen already in the previous YouTube videos how if a specific user logs in, then we try to take a photo, then it tries to decide. We have a backend service and the front end view. When the photo is taken, it tries to decide whether this specific user who has logged in, whether this is Tejas or not. How there is already an S3 references of the Tejas image, which has already been preloaded in my S3 bucket. So this helps and helps to verify whether the current user is from the referenced images, if that matches or not. In order to do this matching, we have something called AWS recognition, which works. And that's where we have this confidence percentage, which tries to evaluate what kind of confidence does it has whether the logged in user matches with the existing reference images of Tejas user, huh? Of the Tejas. Huh? So with that, we get a confidence percentage, and then that determines whether the logged in user is Tejas or not. This is something which we have already done in the previous project. I thought, why don't I use that functionality over here as well? So here, to go in detail now, let's go step by step in detail. I'll try to make it half view. So hold with me now, be with me now. We will go in detail about how the things are happening. The overall architecture looks quite simple when we see in detail how exactly each and every functionality works, right? So first and foremost, let's say if the user logs in, okay? So when the user is trying to log in, we are trying to put the username, we're trying to put the password, right? I only know this username and password, but somehow it got leaked. Then we have two-factor authentication. I'll quickly open my two-factor app, like Protect app. Maybe I'll share a different screen. This is my Protect app. I'll open that. I'll put the value, the token, 145340 is my authenticator code token. Now I'll click sign in. It is trying to take a photo right now. Okay, it is trying to take a photo, it is trying to sign in. Okay, now keep an eye on look. On this verify. First, what has been called as slash verify, then there was login, right? In this verify, we have something called the response is something like this. In the verify, it is trying to verify first and foremost if the user, the photo which has been taken, whether it verifies with the Tejas referenced images that has been stored or preloaded already in S3 from the previous project. So how it does that? It is calling this slash verify URL or API endpoint, some HTTPS something something slash verify, and then it is trying to do a post call. So here is the slash verify. It is trying to do a post call to this Express API, right? To showcase the code of this, here it is. By the way, repository image something it was called is captured image stages backend. Huh? So this is the API endpoint for slash verify, by the way, where you have the complete code for this. When you do this post invocation, it gives a response, is match true? If it is true, that means it is Tejas. If it is false, that means it is someone else. How does it does that? As I said, there is a confidence percentage or confidence number. We have this confidence number as 0.99. That means 99% this is Tejas, the captured image, because it was me already, as you know. The threshold was 80%. Even though there is a 99%, I have kept a threshold of 80%. That means if the 80% of the chances, if the logged in user is Tejas, then the face verified as Tejas, right? If, because 99% is greater than 80%. If the face verified is 82% as well, which means 0.82, even then the threshold is 80, even then the face verified is as well Tejas. But in case if the threshold, if the confidence value is 0.78, that means 78%, the threshold is 80, then it will say that verified as not Tejas. I'll try to do that. I'll try to mimic that. Let's see. I'll try to clear it. I'll try to put the username, password correctly, even the authenticator app value correctly. 467870. Then I'll try to cover my face. I've covered my face so that it doesn't recognize it as me. You see, you see, bro, you're not Tejas, right? I try to make it funny a bit. Coming back, you see, the confidence was 0.07, right? It was 0 percentage. So since it was 0 percentage, way lesser than the threshold, it says face did not match. The threshold value was different. So that's how this post verify call works. It invokes this verify lambda, which means it is not even trying to validate the username, password, and authenticator if the verify itself fails. Okay, if the verify itself fails, the verify API endpoint itself fails. Once the verify is passed, I'll try to re-log in. The authenticator code is different now. Okay, I'll try to, the authenticator is 574925, but I'll try to re-log in with the same face. Now you see a different, huh? The verify now, second time when I've logged in, the verify, the response was 99%. The face was verified as Tejas, because it was 99%. Everything was good. It was 200, okay. But the login failed, because after the verify, once the face was captured, the post verify was called, the face was captured, everything was fine. But the authenticator, as I said, the authenticator value was different because it was the previous authenticator code value, and the current value was different. At that time, it said, bro, you're not Tejas again. It was unauthorized because the verifying point was right, but the login URL, which is slash login post URL, the post endpoint for the login URL, which is this, that had an issue right now, right? One factor was fine, but the other factor, the authenticator code factor, which was the two factor, the second factor, I would say, that failed. If you see in the response, invalid TOTP token, TOTP code. Now, let's say if I put a right TOTP code as well, 302.937, but I'll put a wrong password. I'll remove some value from my password, right? Now we are trying to simulate, the username is right, the password is wrong, the TOTP token is right, the face is right. Still it says, bro, you're not Tejas. You know why this time? The face was verified 99%. Now in this time, it said invalid credentials. Again 401 unauthorized, bro, you're not Tejas. But from the response perspective, it is invalid credentials because the password was wrong. So that is the third layer of authentication, right? The first, verify. Even though the username, password, and authenticator code it is verifying later, first the verify is trying to slash verify is trying to verify with the face recognition whether it is Tejas or not. The second verification we have seen with the authenticator code, if I'm trying to misplace it, even then, or if I'm trying to misplace the username or password, even then it would say invalid credentials. I Ideally I should have made it much more secure. I should have, even in my response, I should have not made invalid credentials or invalid TOTP token. Rather, I should have made it generic so that it gets difficult to guess whether the mistake is from username or password or authenticator code, or even in the verify I could not have this kind of response, which is very easier for any hacker to know which three layers has the issue. So again, it is quite difficult to crack this. In case if you want to give it a try, I would leave it as it is. You can feel free to crack it. So once username is right, password is right, authenticator code is right, only then it would try to log in, right? I'll try to log in with a valid token and everything this time. It is capturing me now again. So this time, shit, I have not write the right password. I think the token got expired in between. Shit. No, I was able to get in. Okay, the verify worked. Face got verified. Even the login response was fine. In the login response, I got token. Now, um, since the verify was fine from the facial recognition, the login was fine, the username password was fine. Then it had went to SSM and fetch the token, the JWT token, the bearer token, and it has given this bearer token. This is the bearer token, right? And from this bearer token, admin authorizer is using it to get the YouTube matrix here, to get the GitHub contribution matrix, which is here in the response. Similarly, the cost explorer matrix from the AWS as well. Complete cost, that how much is. So all this get calls have been made to fetch the relevant information, and only once the token was authorized. So before jumping into this, we will see the Express API, the complete code. The YouTube tutorial is already there. I'll have the link in the description. You can follow that. I'll try to get into the admin login Go Lambda. We'll see now in terms of code as well how interesting it is. I'll quickly open this. I'll open the VS Code. Okay, collapse all. So under infra, lambda, CMD, I have all my lambdas, right? So now we are interested to check. I'll keep it here. We are interested to check first and foremost the slash verify here. Since this is not part of this lambda, as I said, it is part of the other lambda, which is the is captured image backend pages. So that's where you have this API endpoint slash verify. This is not part of this repository. So it is invoking slash verify. The front end part of it, the admin login.jsx, the front end part of it is trying to invoke slash verify endpoint URL. It is trying to fetch that, doing a post call. Once it gets that response, then we are calling. Once the verify is done, then we are trying to call the admin login. So the login now goes to, I'll go to the, here is the login you lambda. This lambda, the admin hyphen login lambda, what it does. Huh? So the code is quite straightforward. Here we are trying to check. Firstly, we are trying to fetch the required credentials. Firstly, we are trying to see if the request body is valid or not. If it is invalid, we are trying to stop it. Then we are trying to fetch the secrets. We'll go to the AWS secrets. We'll try to fetch the JWT secret. We're trying to fetch the TOTP secret. We are trying to fetch the admin credentials, right? We are trying to fetch the admin credentials. In admin credentials is where we have the username password. We'll quickly go there. SSM. So we are more interested with TOTP token, credentials, and secret. In the slash admin slash credentials, in the SSM, we have the username and password. I'll not try to click on to retrieve the secret value, but here is where we have the username and password. So we are trying to fetch that. We are trying to fetch that specific credential, the username and password. Then we are trying to also fetch the TOTP secret, right? The TOTP secret, I'll not relieve the credentials is where we have username and password. Then, as I said, we have the TOTP secret. Here, I will not retrieve the secret value, but here is where we also have the TOTP secret value. From this secret value, we are trying to get that value as well, and trying to validate if that specific value and the one which the user has logged in from his token, if that both the token valid or not. We will see in a bit in detail about that as well, how exactly it works. But here is the code snippet for the TOTP secret, fetching it from the AWS secrets manager, and then trying to validate if that if that code is valid code or not. This is where we are using this validate code, and we are trying to validate the token, the TOTP token. When we are trying to see the generate secret, we will see how exactly it is working. But for now, you can think about the validate code is actually helping to validate the TOTP code. If all this are valid, the TOTP code, the username, and the password, if all this are valid, only then we are trying to log in, right? That's what we have seen. And once we are logged in, then we are trying to have the we are trying to attach this token value. The token was here, right? Once you're logged in, then you have this JWT token attached to every response. So whenever any of this invocation is happening, in the header, in the request header, you will have the bearer token, the same bearer token that was generated out of login, right? So something like NJR in the login response, you should have at the last NJR. I'm just trying to say that this is the same JWT token. Once you have logged in, verified from the authenticator, verified from the backend face recognition app, the Express API, then also from the admin login where the username and password was fetched and validated, verified whether even that is similar. Only then the login was right, and then you get this token generated. That JWT token is used, the same token is used for other invocation as well. When you're trying to do the get call, right, the same JWT token would be used. So yeah, this is about the admin login. Next lambda we would be more interested is the authorizer lambda, the admin authorizer lambda. As we have seen what exactly the admin authorizer lambda does, it does two job. It does one job, to be very specific. It takes that token, right? It takes that JWT token. Using this token, it tries to validate if with this with this authorization bearer token, it tries to validate if the if the specific login or the specific session, if it is valid. If so, then it would return and allow the IAM policy to the API gateway. If it is not valid, if it is invalid, then it would deny the policy, the IAM policy, and returns the 401 to the API gateway. So every request that you're trying to do, which means, let's say, if I am trying to do every request, if I'm trying to go back and try to do admin slash dashboard, you see, directly I was able to log in slash admin slash dashboard because my JWT tokens time to live, the TTL for JWT token, I think I've kept it for 1 hour. So because of that exact token value, my admin authorizer was okay to have it. The session was still valid. That's why it was returning the IAM policy to the API gateway that okay, this is a valid token. You can still proceed with the request to fetch the YouTube matrix, request to fetch the GitHub contribution, so on and so forth, when it went to admin dashboard. Okay, the code is here for the admin authorizer. In the handler, we are trying to call two methods if it is valid or invalid. We are trying to verify it. If it is invalid, we are trying to deny it. If it is valid, we are trying to allow it. In the allow, we are trying to have the IAM policy. As I said, we're trying to ensure that the IAM policy is executable, and we are letting the API gateway say that hey, now you are authorized and you can execute this specific API invocation. If it is invalid, we are trying to deny that. Basically, with the effects, we are trying to say that this is invalid bearer token, so you're not allowed to go inside, and we're trying to say 401 unauthorized. That's what admin authorizer lambda does. Then once we are trying to invoke the specific lambda, from here the job is quite simple. um, I think I've already said that for the admin authorizer, we are trying to fetch the JWT secret. We're extracting the token value and trying to verify with the bearer token that is requested whether that matches or not. If this extracted or the stored SSM JWT secret, if it is invalid with the current request of the authorizer bearer token, or if even if it is unempty, then we would go into the denial mode, the deny policy, and we'll return 401 to API gateway. That would let the front end know that hey, you're not you're invalid user. That's how we are trying to do that. So now once we are logged in, admin authorizer is good. If it validates, we got a returned IAM policy as API gateway can forward the request to the targeted lambda. So in the targeted lambda, let's say for the admin YouTube matrix, we have I've seen this. We have seen the login. We have the YouTube matrix. In this YouTube matrix, this is again a dedicated lambda which fetches. The job of this lambda is to fetch the or to do the get. Does a get invocation. It gets the channels statics for handle YouTube URL. So basically from the YouTube data API version 3, which is Google, so Google's YouTube data API, the Google API, from there we are trying to fetch the YouTube data. How did I do that? I have already signed up um, as a developer's account. I don't know whether I think I've already kept it here. In the console.cloud.google.com, I've already signed up for the API services. And there, I'm very much interested, already generated the secrets and all. I'm very much interested with the YouTube stats. So I've generated the API key, dedicated API key. This API key value, I'll not showcase now because it has my secret value. This API key value, I'm storing it in my secrets. YouTube API key. Right here it has that secret value. So I'm trying to fetch this YouTube API key secret. At this part, I'm trying to fetch this YouTube API key secret. First, I'm trying to do this SSM. I'm trying to fetch from the SSM YouTube API key secret. Here it is, /admin/YouTube API key secret. So I'm trying to fetch from my secrets manager, from my SSM, the YouTube API key. And that API key, I'm trying to have it invoked into my get call. And here I'm trying to use the environment variable. In my environment variable, I have already wrote it is for @t sabunkar. So so it ensures that it is for T Sabunkar, um, for the T Sabunkar handle, and with the key value, the API key value, the YouTube API key value, which I fetch from the AP from the SSM secret. I'm trying to use that value to fetch my stats from the Google API, right? To fetch the stats from the Google API. By the way, you can find this in the library. You can just type YouTube. This is the one, YouTube Data API version 3. So this is where I'm using this YouTube Data API version 3 to do this API call to fetch or retrieve my YouTube stats, the YouTube data. How many videos or the playlist or the channel or whatever, all these details or the stats, I can fetch it from the YouTube Data API version 3, which is the Google's API endpoint. I did not hard code the YouTube API key in my in my environment variable because it is easier to hack it. Rather, it has been stored in SSM in my secrets manager, and every request I'm fetching it from my secrets manager, right? Secret client, which is this secret client, AWS secret client, and yeah, I'm trying to do this YouTube version 3 API invocation. With that, storing fetching the dynamic value for my percentage s, the handle name, which is T Sabunkar, and the key, the YouTube API key, which I'm fetching it. This is for the complete YouTube feature. So you can quickly see here. This is the YouTube feature, the JWT secrets. By the way, this feature, the YouTube channels feature. And in my response, I will have the the matrix, the YouTube channel matrix, which the Google API is providing. Similarly, we have the Google contribution, the GitHub contribution, which is another Lambda, the GitHub contribution Lambda. Here is where I'll quickly show. Here is where we are using the same concept where we are fetching the GitHub token. The GitHub token is again stored in my secrets. I'll go to secrets, the GitHub token. From here as well, I'm fetching the GitHub secret, and with this GitHub token secret fetched from SSM, this lambda, it is trying to do a post invocation to GitHub GraphQL API, which is here, GitHub GraphQL API. I'm trying to do the post invocation to the GitHub GraphQL API with the query. This is my query. Since it is GraphQL, the query style is different from the REST way of dealing. And the GraphQL request, the query request would looks something where it is username. From this username, what are the different contribution collections, so on and so forth, right? How exactly the contribution is happening, or on the day-to-day basis, how the contribution is happening. All this information I'm trying to fetch in the JSON format, which you can see here. The response is in the JSON format. I'm trying to fetch that response. And with this response, I'm trying to generate the GitHub contribution, which is here. The GitHub contribution, how my contribution is happening over the last year. That detail I'm trying to fetch it here and showcase in the heat map format. So yeah, this is for this is the lambda for the GitHub contribution. Similarly, Google is done, GitHub is done. Similarly, for the AWS part as well, we have let me close this, the cost explorer lambda. In this cost explorer lambda, um, we are trying to fetch from so and so date to so and so date. um, we are trying to fetch the cost estimated, right? We're trying to fetch the total cost, the daily average cost, this month's cost, this week's cost, last 2 days cost. All this information we are trying to fetch it. But here we are not doing any API call, because since we can directly use AWS SDK, the AWS SDK is client. And then we have field AWS SDK's client. You can see here AWS SDK's client, and we have field we can directly fetch the values from the cost explorer itself. Huh? So no dedicated API call is there, unlike what we have done for Google and GitHub. Since we are in the since the all our services are deployed in AWS, this makes my life easier. Directly I'm trying to fetch it via SDK, AWS SDK. Go, I'm trying to fetch the cost explorer, and try to take that value and use that use that to have this kind of graphical representation, and then the values of my cost and usage, right? Which is here, the cost explorer. All this value fetched in the JSON and then drawn as a graph in my front end with the same request of the bearer token, right? So yeah, overall, this three features right now I have. In future, I'll expand this as well. There is one last thing which we wanted to see about TOTP token. Now, I think this is something very really interesting. What we will have for this, I think the video is becoming too long. I'll stop this now. In the next tutorial, we will see how we are using the TOTP token. Be with me, because this is very interesting. How we will see how we will generate a TOTP token, how we will what exactly the TOTP token is. We will understand a bit of theory, what the TOTP token does. We will see in the Golang what is the features that are available to create or generate this TOTP token, and then we will see how we have used that, and we will do a live regeneration of TOTP token and how it works. Huh? So for that, we will we will stop here. We will see that in the next tutorial or next video. Thank you.